Is this all right? Everybody sees the screen quite okay, or you guys want to come closer, maybe? It's not, it's not school, I mean, it is a school, but you can come in the first row. Okay, so is the sound recorded as well? From the mic? Recording from the mic as well, right? Okay, cool. Just a sec. Okay, hi everyone, I'm Alex. I'm part of Request Network. I handle community, communications, business development, and all the fun things. Joining me today is David from Ohio. He is our senior blockchain engineer. He wishes he could be here with us, but he's got some personal problems, and he cannot make it, unfortunately, so we will do the technical workshop kind of remotely. I'm gonna give you guys a quick intro on what Request Network is, what we do, what we also want to do, and then David will take over and give you guys a quick tour of the protocol, the easiest way to implement it, and what you can build using Request Network. First things first, what is Request Network? We are an OG crypto protocol from 2017. We were born out of an ICO, if you guys remember the ICO Wild West era of 2017. The original vision of Request Network was to break down the financial silos and to create an alternative to the traditional financial system. So what we have done in those 6 years, you might have heard of a product called Request Finance. That is our biggest product, our biggest player in the ecosystem. It's an invoicing and payroll solution that is used by all the big crypto companies that want to payroll their employees in crypto or crypto to fiat. And it's also used by all kinds of freelancers that want to be compliant, be legit, have an invoice to show for their services. So this was built in a couple of years. It is now the go-to solution for invoicing and payroll. And in the meantime, the protocol, Request Network, is building up an ecosystem involving Request Finance as well. But we're building up an ecosystem that wants to cater to everybody. So every category of people in the world, the unbanked people, the people that don't have access to banks, to loans, or any service without all the papers, without all the identity, all the transactions that you have in your life, the transaction history. So we're looking to help those people, and we're also looking to help everybody that has had problems with banks or PayPal. You can think of us as the next iteration of PayPal. So everything is going nice. We have hired a new team recently in the past couple of months that is looking to grow the ecosystem. The biggest player, like I told you, in the ecosystem is Request Finance. We have six new grant recipients that are building together with Request Finance and together with us. And some of them maybe have heard of Huma Finance. They're doing loans. Or maybe Copra Finance, who are doing uncollateralized loans. So basically, what it means is that if you have an invoice, a standing invoice in the Request Network, you can use that future income to get the loan now. It works right now. You can try it right now. You can get the loan without having any money right now, which is, I mean, at least for me, it's pretty mind-blowing, right? Uncollateralized loans. And this is just a taste of what we can build. We are eager to build anything that goes into payments, into invoicing, into accounting, into financial, any kind of financial product or service that you can find in a bank. We want to provide that to people, and we want to provide it to everybody. We want to be inclusive. We don't want to be exclusive, right? So our whole ethos, our whole raison d'etre, our whole reason to be is to create an ecosystem. This is it. We've built a product, we moved on, and now we want to create an ecosystem. We're a foundation. We are very similar to what Solana Foundation does or Near Foundation. And to build that ecosystem, we have developed a grants program, an encompassing grants program that helps people bring their vision to life. And how do we do that? You apply to us with a form. It's quite easy. You fill out the form, and then you have a couple of meetings with us, a couple of team validation meeting, business validation, technical validation, and then you will get some money so that you can start building your vision. We will not build it for you, but we will give you all the tools that you need, including support, on all kinds of support. Other than that, we can provide you with an infrastructure that's been battle tested for 6 years. We've been here for 6 years, guys, and we haven't been hacked once. We haven't rebranded. We haven't done anything to our brand. It's the same name for 6 years. No hacks, no loss of money, no loss of reputation, nothing. So our infrastructure has been truly battle tested, And so far, we have managed to process, if I'm not mistaken, almost 400 million in transactions. And while this may not be a big number, I know, but it's transactions that come from invoicing people. They come from payrolls, like they come from salaries, they come from loans. It's not sort of like, it's not farming, you know? So while it's not a big amount, it's an amount that means we processed enough transactions so that we can call ourselves the biggest decentralized database of financial information. So if any of you want to build something with Request, you will get access to data that will easily allow you to provide any kind of financial service, simply because for many years, people have left a financial trace on our network. And when I say network, obviously, I don't mean a layer 1, I don't mean a layer 2, not a blockchain. With a simple open source protocol, you can find us on GitHub right now. You can look at the repos. You can see all the smart contracts. We are available on 20 EVM compatible chains and near, obviously, because everybody loves near, right? And to close things off, David, our senior blockchain engineer, he's gonna start presenting what is a request, what is a payment request, why are we called requests, right? Why is it request network? So simply because that's how we started. We started by creating payment requests, storing payment requests in IPFS. That's how we started. That's our first step into this world. We started in 2017 by adding context to transactions. Because when you send from one wallet to another, you have no idea what you're sending other than, you know, crypto. But for what? Are you buying something? Have you purchased something? Is this a service? Is this your monthly salary? Are you paying an employee? Nobody knows, right? So 6 years ago, this was the first building block. The transactions had context, which that context enabled all kinds of use cases that I just told you about, right? So based on that building block, David will start from there, from like a quick start guide on how is a payment request looking, how do you create it, how do you store it, and what can you do with it, okay? Cool. I'm gonna flip over to David. Since my microphone is not working, I'm gonna just give him a thumbs up.
Hello, can you guys hear me? Okay, cool. So I haven't heard anything so far. And I'm wondering if I should go into my section of the workshop.
One second.
Well, this is a challenge. Obviously, I wasn't able to make it to ETHWarsaw today for personal reasons, but we're gonna try and do it remote anyways. So hi everyone, I'm David Hunt-Mateo. I'm a senior software developer at the Request Network Foundation. And today I'm just going to be doing a brief introduction of the Request Network and the basics of how to use it and some of the capabilities it has. I believe my colleague Alex already talked to you guys a little bit about the ecosystem that we're trying to build and the vision that we kind of have. So I'm going to move on to the next section of talking about kind of the life cycle of a request. If there's any questions, Alex, could you we'll try to do questions at the end, I think. If Alex is able to take questions and then relay them to me, we can try to do it that way. Normally I accept questions throughout, but I think it'd be hard to do that in this format. Okay. So basically, a request is a JSON blob of data. Really, at its simplest form, it's a blob of data that describes the context for why a payment occurs, and typically it's created before the payment occurs. Although technically it could go in the opposite direction. The typical life cycle is that you start by creating the JSON blob, which includes the payer, the payee, the currency, the amount, and a variety of other details, stuff that describes how the payment should occur, and stuff that describes any other arbitrary content data that makes sense within the application's context. And all of that data then gets written to IPFS. We have our SDK and our request node that facilitates this process, but at its core level, that's basically what's happening. The data gets written to IPFS, and as a result, it creates a content addressable ID. This is a unique identifier for any sort of data that's stored in IPFS, and we take that CID and we store it on chain. In particular, we put it on Gnosis chain for our real requests, and then we put it on Goerli for our test requests. So once the data is persisted in IPFS and stored on chain, we consider that the request is created. It's fully formed, forevermore stored on the blockchain, and the IPFS allows anybody to be able to query that data at a future time. The way that you query that data is using the request ID, which is another piece of information that is derived from the contents of the request. Sorry. Okay. Alex was just sending me a message, but I'll go back into what I was saying. The request ID is derived from the contents of the request, and it's stored alongside the request so that you can use the request ID to look up that information in the future. There's a second piece of information that's generated from the request contents, and we call that the payment reference. The payment reference is not stored alongside the request, and that is to create a layer of privacy for the data. The payment reference is the piece of data that gets put into the smart contracts, and it uses the it uses the payment reference to connect the request to any sort of payments that occur on chain. But you have to know the contents of the request before you're able to make that connection. So we generate this payment reference, and we use that as one of the input parameters on all of the different payment smart contracts that we offer. The payment reference is combined alongside the amount that is being paid, the to address, the person who is the recipient of the payment, and the now I'm going to forget. It was the token address, the address that you're actually the address of the token being transferred. So it takes all of that information and puts it into a smart contract call, and depending on the payment network that we're using, that smart contract will do a variety of different things. If you're using the native payment contract, then it's going to attempt to send ETH or whatever the native token of the chain is. If you're using the ERC20 contracts, then you're going to be sending an ERC20 token. If you select a conversion contract, then ERC20s or native tokens, but then it's going to be sending an amount denominated in some other currency, typically a fiat currency like USD. And it uses on-chain price feed or make that conversion at the time of payment. That's just a few of the different payment networks that we offer. I'll get more into that in a future section. But basically, once the smart contract call is executed, the payment is sent, and the recipient receives the funds. It's also worth noting at that point there's the ability to take fees. So if the builder, somebody who's building on Request Network, wants to add a fee for processing the payment, they have the ability to input that as one of the input parameters as well. And then the fee gets transferred to their own address at the same time that the payee receives their payment. So the next step is all of those smart contracts emit an event of some sort. And this is kind of the key that for us being able to detect the payments after they occur. These events contain the key pieces of data that I described. They include the token address, the to address, the amount transferred, and the payment reference, which gets indexed so that it can be looked up by our subgraphs in a later stage. At this point, I'll mention that when you make a payment, in the typical case, nothing gets written back to IPFS. We rely solely on the events that exist on chain to detect those payments. Another thing worth noting at this point is that partial payments are possible. So you're able to send half of the amount or some smaller percentage of the full amount. And the way that our payment detection works is it just takes all of the events with the same payment reference and it adds them up so that we get a total balance for that particular request. The next stage after the events are emitted is that we usually have an indexer of some sort, typically a subgraph or a graph node that reads those events and then tries to reformat them into a GraphQL API that is easily queryable. So from the subgraph, we're able to count up all of the events for a particular payment reference, calculate the balance, and then ultimately pass those data structures back up through our SDK. Our SDK has functions that allow you to quickly query all of the requests for a particular user, or all of the requests that match a particular topic, or a single request looked up via its request ID. And when you make that retrieval call, it's going to go out to IPFS. It's going to take the data that's stored there and combine it with the data that's stored on chain, the events that show the payments. And that's basically it. That's the core life cycle of a request. I will mention that there's also a step kind of in between that I didn't mention is once a request is created, there are a few things that you can do to update and change the. This doesn't mean that you're updating the contents in IPFS. That stuff is all immutable and static, and you can't change it once it's written. But you can append new data onto the end. And so when we're retrieving a request, we can look at all of the events, sometimes we call them events, sometimes we call them transactions. But in IPFS, everything with the same request ID is going to be linked together in a channel, and we're able to calculate the current state of that request. So some of the things you can do the payee can cancel a request if they're the ones who issued it. They can cancel it. The payee can also increase or decrease the expected amount. The payer has the option to accept a request, which is meant to be a signal to the payee that they intend to pay it. And both the payee and the payer can add third-party stakeholders to the request in the case where it's encrypted. So if the request is encrypted, then we have the ability to share that request with new stakeholders after the fact. And I'll get into the encryption in a future section. Another thing that I wanted to mention is that the typical life cycle that I described is referring to reference-based requests. We technically have another type of request called declarative requests, and that's one that is facilitated without the blockchain. It uses actions that we write to IPFS, where the payer is able to declare that they have paid the request, and the payee is able to declare that they have received it. So if you were building an application and you wanted to support a blockchain that wasn't yet supported by Request Network, you could use a declarative payment, a declarative request to be able to represent that in your app in the interim before we're able to support that chain. Similarly, if you're just trying to do fiat payments and you have like bank transfers going on in the background, you could use declarative payments to support that as well. Okay, that's kind of what I wanted to say about the lifecycle of a request. The next thing that I'm going to move on to is I'm actually just going to quickly run through some of the quick starts that we have here in our documentation. This is going to go into a little bit more deeper detail of how to use our SDK and how to do those three core actions of creating a request, paying a request, and then retrieving and detecting the payments of a request. I'll start by going into the quick start for the typical use case that I would see at a hackathon is you're running request network in a browser and you're trying to allow the user to use their Ethereum keys stored inside of a wallet. And I say Ethereum there meaning just like any EVM compatible chain. If you have keys inside of a wallet, this is kind of the quick start for you. In this example, I'll be talking about just creating an unencrypted ERC20 request. If you're interested in talking more about other more complex payment types, or if you want to talk about encrypted requests, I'd be happy to talk after this workshop and we could dive into the details of how to do that. The first thing that you're going to need to do when you're creating a request is you connect or you instantiate your request. Wait a second, where did it go? Oh, interesting. I must have deleted it at some point. Sorry about that, everybody. I'm missing a piece of code that I'm expecting right here at the top. I'm going to scroll down to a separate section to get that piece of code. It looks like this, but I must have accidentally deleted it from the create section. Sorry about that. Okay, so the first thing that you're going to want to do is you create a request network object. And this is callable from both JavaScript and TypeScript. You instantiate this request client and you make sure to connect it to one of the request node gateways. It could be a node gateway that is being run by someone other than the Request Network Foundation. But as of today, we have a couple of node gateways that we offer that subsidize the costs of submitting requests to the protocol. So this one that I have listed right here is the Goerli gateway. If you wanted to connect to the Gnosis gateway, which is for creating real requests, you would just replace this word with xDai right there. Okay, so once you have your request client, I'm going to scroll back up here. Once you have your request client, you would then need to create your Web3 provider. And today, the Request Network SDK does not yet support Ethers v6, but it is able to support Ethers v5, or if you're using WAGMI or VM, you have the ability to create adapters between the VM wallet client and the Ethers v5 provider and signer. So you're going to want to create the provider and connect it up with your whichever provider you're using. If you're the injected wallet, like a MetaMask inside of the browser, you're going to want to use the Web3 provider. Or if you're using a JSON RPC provider like Infura or Alchemy, you could connect your provider up to one of those instead. The next thing that you're going to want to do is create a Web3 signature provider. This is the thing that's going to interact with your wallet and request the signatures required to create the request. Oh, here's the code snippet I was looking for. Finally, we create a request network object right here, and we pass in the connection to the gateway, as well as the Web3 signature provider. The next step that you're going to do is you're basically going to create this data object that describes what the request all of the parameters of the request. It's a data object that contains everything about the core request info. These are the things that I mentioned earlier: the currency, the expected amount, information about the payee, information about the payer, and then there's also a timestamp in here for the timestamp is used for differentiating between different requests that have identical contents. And internal to our SDK, if for some reason the timestamp is exactly the same between two different requests, then it also adds an optional nonce field that differentiates the two. So we can see here that I've added a currency. This currency happens to be the FAU token. There's a faucet, a well-known ERC20 faucet out there for FAU tokens, and it's on Goerli chain. And I've got an amount of just 1,234 tokens, or a way. I don't know how to say it, but this is like the EVM compatible version of the units. If you have to convert units from your front end, you could use something like parse units from either ethers or VM. The payee and the payer are pretty self-explanatory. These are the identities of the parties involved. I will say that the payee described here is not necessarily the address that's going to receive the payment. It's merely an identity to submit signatures for that request and show that they belong to a particular individual. The actual address that receives the payment is described at a lower place, right here inside of the payment network object. So the payment network object, this is what describes the method by which the payment occurs. In this case, I've said that I want to use the ERC20 fee proxy contract, which is a contract that transfers ERC20 tokens and then takes a small fee for the builder if they so choose. I've told it that it's going to be on Goerli chain. I've told it that the payment address in this case is the same as the payee identity, but it doesn't have to be. And I've set a fee recipient of the 0 address, and I've set the fee amount to 0 because I'm not taking any fees in this case. Finally, down here we have the content data. This is kind of a section for arbitrary data. Whatever you as the builder want to include in this section, you're able to. But we recommend, if you're building an invoicing application, for example, that you use the RNF invoice format from the Request Network data format package. This is the same format that, for example, one of our builders, Request Finance, uses. And it has all of the fields that you would typically want for an invoice. In this case, I've chosen not to use that. I've just added some information about the reason. It's a pizza emoji, and the due date is some date in the future, or in the past, I guess. Finally, we have information about the signer, and this is part of what the Web3 signature provider does. Is we tell it who is supposed to provide the signature in the input data structure, and then the SDK automatically sends the request over to the wallet to tell it that it needs to create a request, that it needs to sign a message. So finally, here's kind of the core of it. We take that big data structure that we've just built and we pass it into the create request function on our request client object. And we await the creation of the request. Once this request object is returned, we're then able to wait for confirmation. This is the step that actually waits for it to be persisted in IPFS and then persisted on chain, either on Gnosis chain or on Goerli, depending on where you've set your storage location to be. And then finally, it waits for it to be indexed by the graph. And once you get this data back, you know that all 3 of those have been completed. So all of this is demonstrated within this this code sandbox that I've created here, and I've already got it open in a separate tab. Let's see here. So this is it's meant to be a relatively bare bones sort of demo. Obviously, the CSS is not the greatest, but hopefully that increases the focus on just the core functionality. So I'm able to select the payee identity by connecting my wallet. In this case, the payee identity is the one who's going to sign the request. Technically, it's possible for the payer also to be the one who signs and creates a request, but that's kind of a more advanced feature. So I've got my wallet already connected here, and I can select the storage chain. That's the chain upon which the request is persisted. In particular, the CID hash of the request contents stored in IPFS. That's what gets put on chain. In this case, I'm going to choose Gourley. Next, you can choose an amount. I've crafted this demo so that this is a human readable amount, so I'm just going to put in 1, and it's automatically going to transform that into the appropriate EVM compatible units. The currency, I've got a couple of options for currency here. In this case, I'm just going to use the FAU token. I'll show you in my next code sandbox how to get those FAU tokens. It's pretty easy. There's a faucet out there for it. But then I have the option to select a payment recipient, but I can see that it's already defaulted to my payee identity. I'm going to just leave it as is. The payer identity, I have the option to put one in. And I think in most cases you should put in a payer identity if you have an intended payer. But if you choose to omit this, then it makes it so that anybody can pay that request. The downside to that is that there wouldn't be any sort of automatic notifications for that. You would have to use some out-of-band separate channel for sending the notification to the payer to inform them that a request is pending for them. In this case, I'm actually just going to leave that blank. Then we can set the due date. These are and the reason. These are the two optional fields that I told you about in the content data. So this is the arbitrary data. That's why it's entirely optional. In this case, I'm just going to leave. Well, here I'll go ahead and fill them in. So this one's going to be due tomorrow. The reason is going to be pizza. All right, so now that all that is complete, I can submit this. And the data displays here are pretty basic, but you can see that the app status just switched to persisting to IPFS. So it's waiting for me to sign the request contents. That's everything that, this is the JSON blob that I talked about in the docs just a moment ago. And I'm going to sign it using my payee identity, this 7E address. I've named it Alice in my MetaMask. So I'm going to sign that. And we can see down here, it has just returned the request after creating it, and that I'm now waiting for it to be persisted on chain. So to give you context, the code has this create request call. That's the part that's already returned to me and displayed right here. Right now, I am waiting on this later line, request.wait for confirmation. And I'm going to wait until the request state changes to created and the app status changed to request confirmed. There we go. Okay, so at this point, the request has been confirmed. And we can see that this big data structure has been returned to me. This has a bunch of information. Most of it is just regurgitated of the information that I put in when I was creating it. So we can see the currency is this FAU token. The expected amount is now this EVM compatible version of one token. We can see the payee address is in there, the timestamp. We can see the extension data. That is that's the payment network. We call it extension data here because the content data is also considered part of the extension data. So it's the content data is located right here below it. I think all of that is pretty self-explanatory, so I'm going to keep moving on. There's some additional information here about the extensions. In this part about the payment network, it actually tries to add some additional data. So it looks at the received payment amount, the received refund amount, sent payment amount, and sent refund amount, as well as fee amount and fee balance, a whole bunch of additional information, all of which I believe is calculated from events from the subgraph. Notably, there's a thing in here called the request ID. This is the unique identifier for the request, and all additional updates to the request will have this request ID included in it. Continuing on down, we have the state. We can see that it's in a created state. The creator is the one who I believe that is the signer. We have a balance. This is an important field. The balance is calculated from the events queried from on-chain. So if I were to make a payment and then look at this balance again, I would be able to, balance would have changed. We have info about the currency, the type, it's an ERC20, the address, and the chain that it's on. And then there's some additional information, meta information that you can look at here. Notably, there's the transaction hash. This is one that if you go onto Goerli scan, you would be able to see the transaction in which your request was created. So we can see here, we are making a call submit hash, and the information that's getting passed is we're basically taking the hash of the information in IPFS along with the fee parameters and submitting those on chain. Okay, so I'm going to jump back to my create request code sandbox here. The code is very similar to what we saw in the quick start, so I'm not going to go through it in depth here. I'll focus more on the pay request code sandbox next. Let's jump back here. I'm just trying to think if I want to try and take questions now before moving on. No, I think I'll batch all the questions for the end. Sorry, everyone. Okay, the next section that I want to talk about is how to pay a request. In this section, it starts off very similarly to the creation of a request. You have to create this request client object. But in this case, in order to pay a request, you actually don't need the Web3 signature provider. That's only required for creating the request. So in this step, we create our request network, we connect it up to the Goerli gateway, and we retrieve a request by ID, just so that we can have this request data object that we're going to be able to pay. The next thing that you're going to need is, again, you'll need a Web3 provider, but in this case, you're going to need a signer as well. So you have to make sure that you use one of the providers that provides a signer. If you try to use get default provider, it probably won't work because it's not going to include a signer for you to use. And like I mentioned before, it is possible to use WAGMI and VM with our software. You just have to have an adapter to convert the wallet client into a Ethers v5 signer. So our package, the payment processor package, offers several functions for you to be able to verify that a payment can go through and then submit the transaction to actually make the payment. So some of the functions that we have are has sufficient funds. You can just pass in the request data, the payer address that you intend to pay with, and the provider that is making the on-chain calls. And you're able to get a Boolean of whether or not the payer has sufficient funds. And this should work whether they're making a native payment or an ERC20 payment, either way. Then, if you are making an ERC20 payment, you would want to make sure that the user has granted sufficient approval before you're making the transaction to pay. So we have this function has ERC20 approval, where you can just pass in the request data, the payer address, and the provider, and it'll pass you back a Boolean of whether or not that user has sufficient approval. If they don't have sufficient approval, then we also have a function approve ERC20 that automatically takes care of approving the appropriate amount. You pass in the request data, the signer, and then you wait for the two block confirmations typically for it to be finalized. If you're on a different chain, if you're on like Polygon, for example, you're probably going to want to wait for a larger number of block confirmations simply because Polygon has much shorter block times and larger uncle chains can occur. The next step that you'd want to do is you would take that same request data object and you just pass it into the pay request function. This function reads the payment network information from your request and executes a transaction based on those parameters. So if you are doing a native payment, it's going to send a call to our native payment proxy smart contract. If you're making an ERC20 payment, it's going to send a function call to the ERC20 payment contract. And then if you're using any one of our other more complex payment types like conversion or swap to pay or swap to conversion, any of those things, it tries to take care of that as well. And in all of those cases, you would again wait for 2 block confirmations before considering it finalized. And finally, there is a function call where you just you call request client from request ID. And you do that to look up the latest data for a request. It's going to go out to IPFS and grab the latest information from there. It's going to go out to the subgraph and get all the latest events that are associated with the payment reference before that request. And then it's going to return to you an object that I showed you on the previous screen that has all of the different fields, including the balance, including the appended events in the request, so that you can calculate the full state of what the request is in. So after you make a payment, if you're trying to detect that the payment has actually occurred, you would simply pull this request data.refresh function. And that's going out to the graph each time and checking to see if there's new events. And when you see that the balance has increased or is equal to the expected amount, equal to or greater than the expected amount, I should say, then you know that the request has been paid in full and you can consider it paid. So like the create code sandbox, I have another pay a request code sandbox here. It takes a very similar structure to the create a request code sandbox, but it includes some additional goodness at the end. Before I start, I'll mention that you can get testnet funds to work with this contract, to work with this code sandbox by going to either of these faucets, the ERC20 faucet by PepperSec or the USDC faucet by Block Patron. That will give you the necessary tokens to be able to interact with the 2 currencies that this supports. And I'll just show you real quickly what those look like. There's the ERC20 faucet, and then there's the USDC faucet by Block Patron. So I'm going to quickly create a request again. This time I'm going to do 12. Yeah, that sounds good. FAU token again. The payment recipient is going to be my own address. The payer identity is actually, I'm just going to use my own address again. So I'm going to request payment from myself. Just for the purposes of this demo, you can put in any address there. The due date, I'll just set as a future date, and the reason for this one is going to be ETHWarsaw. Give it ETHWarsaw. So I can submit that. Just like before, I get the prompt to sign it. I sign the message. And what's happening is it's taking that message and it's sending it off to the request node to be persisted in IPFS and then persisted on chain. In this case, since I'm using one of the gateways from the Request Network Foundation, the request node is subsidizing the costs of creating that request. Oh, so from my app status, I can see that it's still persisting on chain. And once it's persisted, I'll be able to make the payment. All right, so we can see that the request is confirmed. I'm already connected to the Goerli chain, but if, for example, I was connected to a different chain like Gnosis, then I would have this button right here that would prompt me to switch to the appropriate chain before making the payment. So I can click this, it'll switch me over to Goerli. And the next step that I would want to do is approve to make sure that all of the necessary approvals are granted. I think in my case, it's going to check if I have sufficient funds, and I will have sufficient funds because I already have FIU tokens. And then it's also going to check the type of the request. It sees that it's an ERC20, and then it's going to check for approval. And it's going to see that I've already approved a sufficient amount. And lastly, I'll be able to click the Pay Now button, and the app status changes to paying. I can see on this MetaMask pop-up that I'm paying with my Alice wallet, and I'm going to be sending funds to this address. If we look at that, we can see that it is the ERC20 fee proxy on Goerli. Oh, I lost my pop. Where did it go? Here we go. We're also going to see that it's transferring It's transferring 12 of these tokens. It's also got the payment reference that's associated with the request. And this token BA6, this is the FAU token on Goerli, the faucet token. Okay, so just to make sure this goes through quickly, I'm going to click and make sure that it's set to aggressive, and I'm going to confirm that transaction. We can see that it is currently in the state paying, and I'm going to wait for it to change to paid. Okay, I have this little pop-up set to show me when the balance has changed. But here we can see that the payment has been detected and it changes to request paid. So if I scroll down in this JSON blob, we can see the balance field. It's quite a bit different from how it was when we looked on the creator request code sandbox. We can see that the balance has updated to 12 and that we can see all of the events, the individual payments are there as well. This particular one paid the amount in full, but it's possible to have partial payments in this section as well. Okay, just real quickly, I want to glance at some of the code that made this possible. Similar to the docs that I showed a moment ago, we can see that the has sufficient funds was called, or sorry, it was called up here. Has sufficient funds was called, has ERC20 approval was called. If I needed approval, it would have called approve ERC20. And then down here under the create request part, sorry, not create, the pay request, it's up above. Inside the pay request function, we can see that it created a request network object, queried it by ID, and then called pay request. and then it had a while loop to check whether or not the balance had changed. So let me jump back to my box here. We've kind of alluded to it a little bit, but it's obviously you're able to retrieve a user's request. The one that I've shown predominantly so far is this from request ID, but it's also possible to query by identity. So you can just pass in an identity address and be able to get all of a user's requests. I have a code sandbox here that shows what that could look like. This would be something of a dashboard page for your users so that they could see all of their requests in one place. In this case, I have it set up to look at one of my other addresses, starting with 519. And we can see that it starts off with this table that shows the timestamps for all the requests, each of the different request IDs, the payer, the currency, the expected amount, the reason, the due date, status, whether it's paid or created or pending, and the balance shows whether or not it's been paid. I mean, the status is derived from the balance, I should say. And then I also, just for fun, I printed out all of the different requests, the raw JSON. So you can take a look at that if you're interested. All of these code sandboxes are easy to fork and play around with if you'd like to. And they're also embedded in the documentation. So if you'd like to try and play around with them directly there, you're able to. I'm just glancing at the time. I've been chatting for about 50 minutes now. I'm gonna share a few more things, and then I think I'll be able to pause for questions. You notice that this first quick start in the browser was crafted so that all of it relied on the signatures from a wallet, basically, the private keys that are stored within either MetaMask or something similar. But that's not the only way to use Request Network. We also have an alternate signature provider called the Ethereum private key signature provider. And this signature provider is much better suited for running its scripts or in backends that might have private keys that they're managing directly outside of a wallet. So this second quick start mirrors the first one. It's just like the browser one. It has the create, the pay, and the retrieve sections. But instead, it uses the Ethereum private key signature provider to use a private key that's stored in an environment variable. So if you're running a server or if you're developing scripts that you just want to try out to play around with the library, you have the ability to do that as well. We have full examples for creating a request that you can actually just copy and paste. You could just copy this whole thing into a script and run it, as long as you create a small environment that imports these packages. Similarly, there's one that pays a request. It creates a request and then immediately pays it. And then all the way at the bottom, we have a small script that you can use for retrieving requests for a given user. As you've kind of guessed already, we have multiple different packages in the SDK so that you can pick and choose which features you want to use. The most common ones are listed up here at the top. There's the request client library that's used for creating and updating and retrieving requests. There's the data format library that has the RNF invoice format that I described. There's the two signature provider types, Web3 and EPK. There is a decryption provider here that if you want to create encrypted requests, you can do so. However, I'll say that right now we only support encryption and decryption using private keys that exist outside of a wallet. I think the ability to do all of that inside of a wallet is pending. We're still trying to scope out how to do that. The payment processor package is for making payments and interacting with the smart contracts. The request node package is for running your own request node if you want to. And the currency package is for managing currency definitions. All of these can be imported either as UMD or CommonJS packages, and you can use the import syntax or the require syntax, whichever works best for you. I already mentioned the request node gateways that we support. Real quickly, I just want to mention that when you're configuring your client, it is technically possible to add a field here called use mock storage, and that will make it so that all of the requests you create actually don't go to a gateway. They just get stored locally in your machine's memory, and then they get wiped out after you finish the script. So that is an option if you want to play around with it. And then we also have a series of internal packages, the stuff that kind of makes the other public external packages work. So this shows all of the different data layers within our software stack. Okay, I think that's all I want to say for right now. I'll open it up for questions. If anybody wants to relay their questions to Alex, we can try and get those answered.
Hi, David.
Hey, how's it going?
Just 1 minute. Hello, can you hear me?
Yes.
Okay. So I want to ask which networks request network support, like which chains, EVM chains?
Sure. Okay. We are on over 20 different EVM compatible chains. A full list does not exist, or it does exist, but you have to like parse some stuff to get there. If you go into our repository, well, I'm just going to name off a lot of them. Like a lot of the popular ones that you might have heard of is we're on Gnosis chain, we're on Ethereum, we're on Polygon, we're on Optimism, we're on Arbitrum, we're on Fuse, we're on Phantom, we're on BSC. I mean, we're on Goerli. I mentioned that one already. And there's others too. If you want a full list, what you can do is you can go into our request network repository. And inside of the request network, where'd it go? Here we go. Inside the packages, inside of the smart contracts, inside of the source, lib, artifacts. So a full list of all of our payment proxy smart contracts exist within this. And depending on the payment type that you want to use, you're going to want to go into that folder, so the ERC20 fee proxy, and go to index. And it's going to show all of the different deployments for that smart contract. We can see that the ERC20 fee proxy, if I scroll all the way down, is deployed on Mantle. It's on Tomb Chain, Moonbeam, Optimism, Ronin, Avalanche, Arbitrum, Rinkeby, Phantom, BSC, XDAI or Gnosis, Fuse. It's on Cello. It's on Mumbai, Matic, Goerli, Rinkeby, Mainnet. And then we also have an equivalent sort of contract. It's not the exact same because it's written in Rust, but we also support Near.
Okay. I want to ask, can we support non-EVM chains?
So it is possible to support non-EVM chains, and we've done that with Near. But today, non-EVM chains do pose a larger challenge to support because it requires a separate implementation of our proxy smart contracts. So if you wanted to support, for example, Solana today, what you could do is you could use a declarative request. So instead of using smart contracts, you would have the payer declare that they have sent the payment, and then maybe they put in the transaction hash or something like that, and then the payee can declare that they've received it. That could be a way to implement on Solana today using Request Network.
Okay, actually, I wanted to deploy on ZK Sync, but ZK Sync is not on your list. So, can we deploy on ZK Sync?
So for ZK Sync, since it is I believe that one's an EVM compatible one, correct?
Yes. Yes.
Okay, yeah. So for that one, you could go the declarative route that I just described, or it would be harder to do, but you could. All of our smart contracts are open source. You could potentially deploy your own version on ZK Sync if you wanted to. But it would pose the risk of you could deploy it there and you could use it, but there might be some time in the future when the Request Network Foundation chooses to officially support it, and we would deploy our own version and try to support our own version for it.
Okay. Okay. Yeah. Yeah. Thank you.
Thank you for the question. Alex is giving me the thumbs up to log off, I believe. All right. Thank you so much, everyone. Thanks for coming to my workshop. Bye.